Cycling exergames can increase enjoyment and promote high-energy expenditure, making exercise more engaging and, therefore, supporting healthier lifestyles. To improve player experience in a virtual reality exergame using a stationary bike, we investigated how different input and output techniques affect player engagement. We implemented a bike-based controller integrating 2 input and 2 output methods. For steering, we compared button controls and shoulder lean movements. For feedback, we integrated adaptive changes in bike inclination and resistance when going uphill or downhill in a static setting with no adjustments to inclination and resistance. We conducted a study with 24 participants to evaluate the 2 steering and 2 feedback methods. Participants cycled through turns, uphill and downhill, while optionally aiming to hit targets like bowling pins. We assessed their immersion, VR sickness, enjoyment, effort, perceived exertion, and task performance. Button steering was easier to use, offering better control and practicality. In contrast, shoulder lean steering created a more enjoyable and engaging experience, but required more skill and effort. While shoulder lean steering increased enjoyment, it also posed higher physical demands and a risk of VR sickness. Further, our results indicate that adaptive modes increase effort and perceived exertion. To maximize engagement and physical activity, body-based controls like shoulder lean steering need to be carefully implemented to reduce the risk of discomfort. The greater enjoyment fosters higher engagement, particularly when players enter a flow state where the increased physical demands become less noticeable. These findings underscore the potential of bike-based adaptive controllers to maximize player engagement and enhance VR exergame experiences, aligning with the goal of promoting physical activity.